Hello and welcome. How many of you are using CI/CD pipelines to deploy to production continuously? I want to see a show of hands. Fantastic. Keep up those hands if you're doing that to Amazon ECS. And keep up those hands if you're looking to learn how to do this more safely, faster, and with more visibility today. Fantastic. My name's Robert Norford. I'm a container specialist solutions architect, and I help customers design well-architected container solutions every day.
Hello everyone, my name is Vibhav. I'm a Principal Product Manager with Amazon ECS and AWS Fargate. I've been with ECS and Fargate for over 4 years at this time, and in this time I've had the opportunity and the privilege to influence most parts of the ECS and Fargate customer experience. Customers frequently tell us that a key reason that they containerize is to enable their software development teams to ship faster, ship more updates to their customers, create more business value. And in today's talk, Robert and I will be talking about deployment best practices we've seen work well for software development teams, both within and outside Amazon, when running containerized workloads. Now, before we get any further, I want to take an opportunity to level set with all of you and quickly go through our agenda for today. We'll spend some time at the beginning doing a brief refresher on CI/CD best patterns and the deployment constructs in ECS, how those relate to CI/CD in general. But we'll spend the majority of the time in today's session talking about best practices for ECS deployments and how you can adopt them. We'll try to leave time at the end of the session for questions, but in any case, I and Robert will be around after the session as well as throughout the 4 days of reInvent. So if any of you would like to chat, please do feel free to reach out. We'd love to engage more. Now, before we go any further, I do want to take a minute to talk about what we consider the main goals for software deployments within AWS and more generally what I've seen resonate with customers as well. Overwhelmingly, where we see most service owners, both within and outside Amazon, care about the most when it comes to their software deployments is velocity. I'm going to take a moment to define what I mean by velocity here because it's a bit of an overloaded term. I want to make sure that we're all on the same page when it comes to it. What I specifically mean by deployment velocity is the frequency at which you deploy. So the more times you deploy in a given period of time, the more we consider your deployment velocity. Deploying frequently brings a ton of benefits to it. High deployment velocity not only ensures that updates reach end users faster, it also usually means that the blast radius of each change is relatively constrained because changes are small by definition. A second order effect of deploying frequently is that it often serves as a forcing function for teams to reduce manual steps in their deployment processes, reducing the time developers spend managing deployments manually and increasing the amount of time that they have to actually innovate for your business. ECS and Fargate are part of what we call the serverless compute organization at AWS. And we consider it our mission to help customers bring their ideas to production quickly. That's why we feel incredibly privileged and proud when customers like Smartsheet tell us that ECS and Fargate help them deploy and ship fast and innovate faster. Now, deployment velocity doesn't happen in isolation, however. Achieving high deployment velocity requires focusing on 3 key dimensions in my experience. First and foremost, safety. Deployments are a time when you're changing software that is running in production and bringing in new software that carries with it a number of risks. Obviously, you're serving traffic. You don't want your end users to see that, hey, there's been an impact to their request because you did a deployment. Then there's the obvious fact that you're serving a new software version and it could carry bugs. If this process is not handled carefully, it can absolutely torpedo your service level objectives if it's not done well. Therefore, for most service owners that we speak to, the top priority for their deployments is to make sure that their deployments happen safely and without impacting any end users. Next up, speed. And I know this is a little confusing since I used the term velocity earlier, but I'll take a moment to differentiate between the two. When I use the term deployment speed, and we'll be using that a bunch during today's session, so please come along with me. But by deployment speed, what I mean is the speed at which a change that you roll out gets propagated from into your production environment. Whether that be in the dev environment, in staging environment, or a production environment. Deployment speed is critically important especially when you want to roll back or roll forward in case something has gone wrong, or there's a scenario when there's a critical CVE and you need to make a change. You need to update software really quickly. Having the ability to deploy, to be able to deploy quickly is super critical in these scenarios and also in generally. As I said again, where velocity means frequency, speed, the rate at which your change actually propagates. Now, as important as it is to deploy safely and frequently, it is as important to monitor your deployments. It is inevitable that at some point of time a deployment will fail, and as such, it is critically important to make sure that you can detect and take action on a failing deployment quickly, effectively, and can prevent that from happening again. When you do all of these things together, that's when we see customers achieve the greatest velocity for their software deployments. Now, without further ado, I'll quickly get us started with a quick primer on deployment concepts as well as ECS concepts as they relate to deployments. So this is a pretty straightforward CI/CD pipeline. Most of you are familiar with what a CI/CD pipeline looks like, so I'm not going to spend a bunch of time talking about this. Basically, just goes from source to build and unit testing to deploying in a test or staging environment, and then eventually going to production. What I do want to mention here is what I do want to take a minute talking about is ECS and Fargate's specific role in this pipeline. So ECS and Fargate's role primarily comes after you've built the container image. Now, how that happens in your organization may vary, depending on what your organization is shaped like, whether you have an infrastructure team that is responsible for deployments or DevOps teams which do both development and operations. But regardless of that, ECS and Fargate's primary goal is to help you take your container image and get it deployed very quickly, whether that be in a production environment, whether that be in a dev environment, or wherever else. This is a 300-level session, so I'm not going to spend a ton of time introducing ECS and Fargate. However, I do want to take a quick moment to talk about the three most important concepts in the ECS in the ECS constructs. Task definition. Task definition is basically your application spec that you deploy to ECS. A task definition basically contains a set of containers that together constitute a unit of your application. This includes things like your container image configuration, the name of the container image, the network configuration, things like that. Task is the actual instantiation of a task definition. So when you actually execute a task definition, what you see is a task. And thirdly, a service. Service is a logical resource which represents a group of tasks, a group of identical tasks which together constitute an application. When you use the ECS service primitive, ECS basically makes sure that there's a certain number of tasks that are maintained in a running state. This characteristic of services makes it particularly valuable for running long-running applications. And as such, for most of the session today, we'll be talking about deployments in the context of ECS services, because that's how customers deploy their long-running applications on ECS. You can use services to deploy all types of applications, whether that be a monolith, it can be a microservice, it can really be whatever your architecture is. It's a fairly extensible resource, which is why customers tend to like it so much. I do want to take a little longer to talk about some new concepts we introduced recently. By recently, I mean literally last month. So two resources and concepts in ECS we introduced: service revision and service deployment. So service revision represents the full immutable configuration of a service when you deploy a service to ECS. This includes things like the task definition, network configuration, load balancer configuration, basically everything that represents a complete instantiation of a particular application version. The next construct we introduced is called service deployment. A service deployment is basically the process by which you go from service revision 1 to service revision 2. It'll help to go through an example here because I know the difference here is subtle. So when you create a service from scratch in ECS, you basically supply a task definition, you provide a load balancer, if you're using one, network configuration, service connect if you're using that, as well as other configuration. ECS wraps all of that up, flattens it, and stores it in the new resource that we call a service revision. Now, whenever you do a new deployment, now the process which stands up this service is the first deployment of the service. Now, the next time when you update the service, let's say you're on container image version 1, you're going to container image 2, and you stand up a new task definition in order to do that, and you deploy that task definition to ECS. ECS creates a new service revision and creates a new deployment in order to go from service revision 1 to service revision 2. Service deployments are a really powerful resource. We think it allows you to track whether a deployment succeeded successfully or not. It also gives you history of deployment. So service revisions and service deployments are stored by ECS for a period of 90 days by default, because we think that's the extent to which an old deployment would be useful. So if you want to go back and look up that, hey, I did this deployment 3 weeks ago and it failed, you can go back, see why the deployment failed, what was the application configuration that you were trying to deploy, what was the previous one, and this can help with debugging. This is available automatically in ECS by default. You don't need to do anything. And is available both in the ECS console as well as the API. One more concept that we introduced earlier this year is the notion of software version consistency. By version consistency, what I mean is now by default, ECS ensures that each task when in a service revision is identical. So what that means is, even if you use a container image tag to deploy if in your task definition you've used a container image tag to configure the application, ECS will automatically will convert that to a image digest when you deploy the service, and make sure that all subsequent tasks in the service are launched with the same container image. We think this is a super powerful construct because this makes sure that all your tasks are always identical. You don't see any divergence. Your customers don't see any divergence because they landed on different versions of the same, different tasks within the same service. One thing I do want to call out is that we got feedback from customers that there are scenarios where it is desirable to not have version consistency enforced, particularly in cases where you might be using, say, a logging or a monitoring sidecar, and you don't own that particular code base. So you don't, and that code base doesn't even necessarily impact your end users. So what we've introduced recently is the ability to disable version consistency for specific containers in your task definition. So for instance, if you're using the CloudWatch agent, for instance, for observability, or a Datadog agent or a Splunk agent, you can say that, hey, I don't want to have version consistency configured for this particular container, and ECS will honor that. This can be configured in your task definition. Now with that, I'm going to hand over to Robert, who's going to talk more about deployment patterns in ECS.
Cool. Thank you, Vibhav. So I'm going to talk about some of the different deployment patterns that we see customers use with Amazon ECS. And there's two main patterns that we see today. The first one is rolling deployments, and the second one is blue-green deployments. So a rolling deployment is a deployment strategy that slowly replaces a previous version of an application with a new version in increments until it's 100% complete. Whereas a blue-green deployment strategy is essentially where I deploy the new version of the application on an identical environment alongside the old version of the application. When you've tested the new version of the application and you're comfortable that it's ready to route traffic to your end users, you can decide to switch traffic over to that new version and then terminate the old version of the application. There are also other strategies that you might be familiar with, such as canary deployments, a type of blue-green strategy where you say, I'm going to shift traffic over to new users in phases, maybe 20% of my users to start with, then 40% until it gets to 100%. Today, we're really going to focus mainly on rolling deployments. and how Amazon ECS helps simplify that process for you. So, when you create an Amazon ECS service, which uses the rolling update deployment strategy, Amazon ECS replaces currently running tasks with new versions of the tasks there. The ECS deployment controller takes into consideration things like task placement strategies and constraints. For example, if I want to spread my tasks across availability zones for high availability using the EC2 deployment type, the Amazon ECS deployment takes care of that. The number of tasks that Amazon ECS adds or removes from the service during a rolling deployment is controlled by the service deployment configuration. And we're going to dive deeper into that today. There are two key parameters to carefully consider for rolling deployments: the minimum healthy percent and the maximum percent. You might like to change these settings to trade availability of an application for speed. And we're going to explore this later in the presentation. The minimum healthy percent is the lower limit. It's the minimum number of tasks in a service that must remain in a running state during a deployment. We default this to 100%. The maximum percent is the upper limit. So this is the maximum number of tasks in a service that are allowed to be in a running or pending state at any point in time, percent of the desired count. The default is set to 200%. It's really important when you set the minimum healthy percent value that the total request capacity can continue to serve the end users or the traffic needs. Now let's show an example. In this example, I'm going to trade some availability for speed of deployment. I've decided to set minimum healthy percent to 50%, which means during the deployment, 50% of the tasks can be stopped. The maximum healthy percent has been set to 200%, which means during the deployment, there can be 200% of the original desired task count during the deployment. So first of all, I have 6 tasks deployed. With a maximum healthy percent of 200%, I can have a maximum of 12 throughout my deployment process. Next, I trigger the deployment by updating the task definition and triggering an Amazon ECS service update. The first thing that happens is, due to software version consistency that Vibhav mentioned, Amazon ECS will stop one task, it's going to start another task, and resolve the container image digest so that all future tasks as part of that deployment are consistent and referring to the same container image. Awesome. Next, ECS decides to stop 2 new tasks and launches 5 new tasks. So I've now got 6 new tasks of my application running. And finally, ECS is going to remove those remaining running tasks. And that's essentially how the rolling deployment strategy takes place. It's a replacement of tasks, the new version, with the old version. And those 2 parameters Vibhav will dive deep into a bit later, but they're really important. Now, let's explore what traffic and capacity might look like for a workload during a rolling deployment. Along the x-axis, I've got time. Along the y-axis, I've got the traffic to my workload. During a rolling deployment, we can see that traffic is gradually drained from the old version of the application as the new version of the application starts getting rolled out for my Amazon ECS service. Traffic to the new version of the application increases gradually over time. But what does total request capacity look like? And when I like to think about request capacity is the total resources, so vCPU and memory, required to run my task or my workload. And request capacity is now on the y-axis. Depending on the minimum healthy percent and the maximum percent, the total request capacity could stay fairly flat. Or it might peak for short times during the deployment. Cool, so that's Amazon ECS rolling deployments in a summary. But what about blue-green deployments? So if you want to achieve blue-green deployments of Amazon ECS, we recommend having 2 Amazon ECS services, one for the old version of the application and the other for the new version. And this is going to be fronted by an AWS Elastic Load Balancer. Could be an ALB for layer 7. You'll need to decide what parameters you use to determine that the new version of the application is healthy and ready to receive traffic. You might look at things like 500 errors during testing. You might look at functional testing, latency, for example, to make sure you've not introduced any new errors as part of the application. Using a blue-green deployment strategy increases application availability, reduces deployment risk by simplifying the rollback process as well. So once all traffic is directed to the new version of the application, the old version can be deprecated, scaled down, ready for the next deployment. So diving into what request capacity could look like for a blue-green deployment, we can see that for a short period of time, we need additional compute capacity in a blue-green strategy. This is going to add some additional cost considerations. This is the trade-off between a blue-green deployment and a rolling deployment, as the old and new version need to live side by side or in parallel. And when you're happy, you can decide to switch 100% of the traffic over to the new version of the application and start removing the old capacity. This is a fairly straightforward example, and from an underlying compute point of view, during the deployment, you might scale out the new environment and scale down the old environment. And from a traffic perspective, it's a similar story to that of a rolling deployment for a time period. During a blue-green deployment, like for a rolling deployment, there could be stages the blue-green version of the application is receiving traffic at the same time as the old version until it's drained. After a configurable time period, for example, the old traffic connections have been drained from the old workload, the new version of the application starts seeing all of the traffic, and the old version is no longer receiving traffic. So you might be asking now, what are some of the trade-offs between a blue-green and rolling deployment? Deployment types are really a trade-off between speed, availability, and cost, as Vib has kind of been mentioning. A rolling deployment requires a lower total compute capacity, depending on those min and max settings you spoke about earlier, and therefore potentially less cost. But it could have slower rollbacks if an issue is detected during a deployment. Ooh. Whereas blue-green deployments provide a faster rollback as the old tasks continue to run in parallel, so traffic can just be shifted back. But it requires additional compute capacity for the time the old and the new version of the application are running side by side. However, during the deployment, you can decide to kind of scale the new version of the application up and the old one down as you go. Now, let's dive into the deployment best practices that can help you release your velocity, confidence, and visibility. And Amazon ECS with AWS Fargate really simplifies deployments for your workload, but it's still a shared responsibility. And we're going to deep dive now into some of those configurable properties that can help you achieve some of the things we've mentioned. So I'm going to need a show of hands again. How many of you in the room are Java developers developing web services today? Show of hands. Fantastic. And how many of you are building event-driven applications that process work from a queue? Cool. Awesome. I would now like to introduce a developer. So meet Nikki. And Nikki is a developer in need. Nikki wants to build something, and they're going to use Amazon ECS and AWS Fargate to do it, as it enables them to focus on their application development rather than infrastructure management. Imagine you recently started as a full-stack developer, and your first project was to implement resilient rolling deployments with confidence and safety for a Java web API, but also a queue processor. I now want to walk you through how to prepare your application to achieve this. So just recapping the three dimensions: safety, speed, and visibility. And we're going to kind of categorize these best practices based on these dimensions. So first, let's explore how I can architect my Amazon ECS workloads to deploy safely. And these are the goals that Nikki has. Wants to minimize the downtime to enable continuous deployments so that it can release features faster and give them to our end users. We want to prevent bad changes reaching end users. And we want a consistent experience for end users. We don't want our end users to notice that there's a deployment there happening. So first of all, we need to define some application health. For a safe deployment, we need to understand when our application is healthy to start receiving traffic. And this means different things. Applications might implement different health check mechanisms. But for both web API and queue processors, it's likely going to be a HTTP endpoint that returns like a 200 OK status code that says my application is ready to start serving traffic. And this is really important. The developer is responsible for implementing these health check mechanisms and these endpoints. And they should be generally soft health checks. And for languages like Java with just-in-time compilation, the health check might also load other parts of the system to reduce just-in-time latency after the task is marked healthy. You want to be careful with setting deep health checks, which also inspect that the upstream services of that microservice are also healthy, as this could result in cascading failures. For example, imagine I'm a microservice, and I'm validating that I can connect to my upstreams. If my upstreams are unhealthy, it could cause my health check to fail and also implement the upstreams that are calling me. And that's really important. So these health checks probably want to be soft health checks that validate that this independent microservice or application is ready and healthy to receive traffic. Cool, awesome. So that's the first thing. We need to define what does application health mean. And Amazon ECS allows you to define health checks for your containers. So you can set container health checks as part of your task definition. When a health check is defined in the task definition, the container runs the health check process inside the container and then evaluates the exit code to determine whether the application is healthy. So for example, you might use curl to validate that my API returns a 200 OK. The amount of time that Amazon ECS Service Scheduler can wait for a task to be healthy is determined by the container health check settings. So the interval, which we default to 30 seconds. The timeout period, how long am I going to wait for that connection or that request to respond? The start period, and the number of retries that I'm going to try before I say, hey, this is not healthy. And these are really important. The next, for load-balanced applications, so those web and API workloads, you can also set health checks on your load balancers to prevent those bad changes reaching production. So these health checks are also testing reachability. Can I connect to that service running or that task running on Amazon ECS? And that's really important. And the important properties to think about as part of the health check configuration here is the initial grace period in seconds, the health check, the interval, so how frequently do I check that health check, and also the healthy threshold. And Vibhav is going to talk about how you might tune these to speed up deployments, slow down, etc. in a bit later. So really, you're probably going to be looking at sending a combination of container health checks and also load balancer health checks to confirm reachability. And personally, one of the most important things that I advise, or that I see that might often be missed out, is that during a deployment of any service, my application needs to be able to handle voluntary disruptions. So Nikki needs to make sure that when the application returns a SIGTERM, which is a Linux syscall that says, hey, I'm going to start shutting down your process, the application needs to know how to stop accepting new traffic. If the application doesn't start shutting down in time, a SIG-kill might be sent to the container, which forcefully terminates that particular container. And this can be tuned by the stop timeout and also the ECS container stop timeout as part of the ECS agent. It's really important that our workloads can handle these voluntary disruptions. And a voluntary disruption is a deployment. We're expecting it to happen. We want to make sure that our application can gracefully shut down so that we're not impacting our end users there. So this is one of my key takeaways that I like to kind of think about is really, really important for deploying safely. But what about my infrastructure? We've spoken a lot about the tasks and service deployment settings, but what about the placements of my tasks across my capacity? How do I spread my tasks across availability zones for high availability? If you're using the AWS Fargate deployment type, Amazon ECS manages this for you, which is awesome. For Amazon EC2, you can make use of task placement constraints or strategies to say, hey, I want to make sure that when I deploy new versions of the task, I want to try and spread them across availability zones for high availability. So that's when using the Amazon EC2 deployment type. You might have seen the new feature that was launched recently that talks around Amazon ECS availability zone rebalancing. So maybe, for example, during an infrastructure event, one of the availability zones, maybe having some interruptions for your workload, Amazon ECS will notice that the tasks are unbalancedly distributed across those zones, and it will try to rebalance them for you. So I do highly recommend checking that out as well. Fantastic. So we've spoken a lot about those web and API workloads, but what about that queue processor that Nikki also needs to implement? And queue processors are really interesting. During a deployment, we might want to say, hey, we don't want our workload to be interrupted during a deployment because the cost to start processing the work again is great, and it's going to impact maybe an end user or a process. And there's a feature of Amazon ECS called task scale-in protection for those worker-based nodes. So as part of kind of your application, when your application goes, there's new work to be processed, so it could be polling from an Amazon SQS queue, it goes, hey, I've received some new work, I'm going to enable task protection. What this means is that this task cannot be terminated until that expires or it's disabled. Fantastic. So during a deployment, it's going to block it until it finishes processing work. Fantastic. So I finish my work and I disable task protection for that task. The next thing you need to do is think about the visibility stuff that Vibhav mentioned. Your application wants to check, has there been a new version that I should be before processing or accepting new work? So is there a new version of the Amazon ECS service that I need to deploy before I start accepting new work? And if there is, don't accept new work, get terminated. Cool. So I guess, Vibhav, we've spoken a bit about safety, but how do I balance like safety and availability with the speed of deployments?
Thank you, Robert. That's the classic trade-off, isn't it? It shouldn't have to be, though. We at AWS care deeply about both safety as well as speed. And so let's talk about how we can help Nikki and all of you speed up your ECS deployments without impacting availability in any shape or form. Now, at a very high level, there are three key levers that you can use to influence the deployment speed for your rolling deployments in ECS. First one is the speed at which ECS schedules new tasks and shuts down old tasks. Second, how quickly your new tasks launch. And third, how quickly your old tasks shut down. Let's go through these one by one, and let's start by talking about the easiest one first, which is changing the scheduling speed. This is probably the easiest lever that you have to influence the deployment speed for your rolling deployments in ECS. As Robert already walked us through, there are two levers, max percent, min healthy percent. I'll go through the easy one. Max percent, almost always set this to 200%. This configuration basically makes sure that ECS always has headroom to launch enough tasks to get to a successful deployment. Your deployments cannot be faster if you set a value of 200%. However, there are scenarios where you need to set a value lower than 200. This is typically when you might have downstream or upstream dependency limits, things like database concurrency limits, which might limit the number of tasks that you can have concurrently running. But keep in mind, when you set a value lower than 200% for max percent, it can impact deployment speed. Secondly, and this one's a little more tricky, and this is where more of the speed and availability trade-off comes in, is min healthy percent. So as Robert mentioned, min healthy basically dictates what is the minimum number of tasks that are kept healthy during the deployment. Now, if you set this value to less than 100, ECS can start aggressively terminating tasks before it launches new ones. However, that comes with potential availability trade-offs. Therefore, the way I would recommend Nikki and you all reason about it is that max percent, almost always 100 unless you have to change it because of some dependencies. But for min percent, in say something like a dev environment, you probably want to use say 50%. That will allow your deployments to complete a little more quickly. Whereas in production, almost always a good idea to use min healthy as 100%. Cool. With that out of the way, now let's look at the other two levers, which are task startup and task shutdown. However, both of these have much to do with the actual task, the life cycle of an individual task. So let's take a closer look at what the life cycle of an individual task in ECS looks like. So once a task is scheduled, it goes into the provisioning state where ECS basically finds infrastructure to launch your task. Once infrastructure has been found, ECS puts the task onto that host, and the ECS agent on the host starts doing a bunch of work. This includes pulling the container image, unpacking the container image, starting the application. once the application is running, if there's a load balancer configured for the application, ECS connects the application to a load balancer. And finally, once your task is ready to shut down, ECS drains any load balancer connections and then eventually sends a SIG term to tell the task that it needs to gracefully shut down. Let's start by looking at how Nikki can optimize task launches. And specifically, let's start by looking at the pending state, which is where a bunch of the work happens. Now, before you start going and optimizing the pending state, it's a good idea to actually understand what you're optimizing for by measuring where the bottlenecks lie. And in order to do this, what I find most useful is to actually describe a task and look at a few specific timestamps in your task. So look at what time the image pull started, what time the image pull completed, and what time the task was started. Between these three, you can basically decipher how much time my container took to pull the image, how much time it took to unzip it, and get the application into a running state. It basically represents the time in which your application stays pending. There's a bunch of things, depending on what the size of your image is, what the nature of your application is, there's a bunch of things that you can probably do to speed up your task launch. And let's talk about those. So, but before we do that, let's take a closer look at what actually happens during this process when ECS attempts to launch a container. So let's say the container run has been hit. The first thing that happens is that the image manifest is pulled, as well as the various layers of the image, which represent all of the dependencies for the particular container. Once all of the layers have been pulled, each of the layers needs to be, because it's pulled in a zipped format, it needs to be unwrapped, unzipped, unpacked, so that the application can actually start running. Then the application needs to start running. Each of these steps adds latency to a task launch, and all of this is super important, particularly in the Fargate case, because in case of Fargate, each task is launched onto a new VM, and as a result of that, there are containers. Whenever a task is launched on Fargate, a new set of the container images have to be pulled from the source repository. There's a bunch of obvious things that Nikki can do to optimize her task launches. First, build better container images. Nothing as obvious as that, right? Like reduce any unnecessary dependencies, only use the minimal set of packages that are important. That can obviously help reduce the amount of time it takes to download the image. The other thing she can also do is use ZSTD compression. This is a compression this is a lossless compression format that allows for pretty significant savings in terms of in terms of the amount of time it takes to download the image, because it reduces the size of the tarballs. However, there's a trade-off here. The more the image is compressed, the more time it's going to take to unzip it. So there's trade-offs here, and you'll need to look at that a little closer. The other thing, and this is super relevant for slow starting languages like Java, is to use something like checkpoint restore. This is this is something that we've started seeing customers adopt relatively recently. But basically, what checkpoint restore means is that instead of the JVM starting from scratch, you take an image that is that's snapshotted after the application has already been started. This basically reduces a lot of the time that is incurred when you're actually starting up the JVM inside of your container. One thing I want to call out here is that until recently, using checkpoint restore required Linux kernel privileges, specifically sysadmin privileges, which aren't available for tasks that are running on Fargate. However, this is no longer the case. You can now use checkpoint restore with just by having process ID name control. That is possible on Fargate. You can configure sysptrace capabilities for your Fargate tasks, and if you do that, you can use checkpoint restore for your Java applications that are that could be slow starting otherwise. However, let's go back to the container image launch process. One thing that research has demonstrated is that copying downloading the container image and unzipping it represents the bulk of the time that the container takes to start up. What if you didn't have to download all of the contents in order to start it up? Because only a small amount of the container image is actually needed to start up the application. Lazy loading is a concept recently introduced which allows downloading of the container image to happen in parallel while the container is started. AWS recently open sourced a technology called Sochi, or Seekable OCI, which basically supports and simplifies lazy loading of containers. It's pretty powerful and cool. We've seen a lot of customers use it since its inception. It doesn't require any code changes. All Sochi needs in order to speed up your task launches is basically a manifest in front of that or an index that it can use to basically pull the specific bits of the image that are needed to start the application. And adding this manifest or index doesn't need restarting or rebuilding your container image from scratch. We have a bunch of tools out there. I've linked the respective resources that you can use in order to adopt Sochi. Sochi works out of the box with Fargate. You don't need to change your task definitions. This is available for all Fargate tasks running on Linux, platform version 1.4. You don't need to, as I said, you don't need to change your task definition. You can easily roll back. One thing I do want to call out is that lazy loading, we've seen the best results for lazy loading when container images are larger than 250 megabytes in size. That's pretty common when you're running a Java application or even other types of applications. So if your application, if you see your container images needing that or more space, it might be a good idea to look into Sochi. Now, if you really want blazing fast task launches on Fargate, you can couple together Sochi and checkpoint restore, and that will not only make sure that your task, not only make sure that your bits are loading faster, and your application is starting faster. It's also starting the amount of time that is incurred in actually starting the application is reduced as well. So using both of these solutions together can end up in a significant improvement in your performance for your task launches. Now, now that we've spoken a lot about the pending state, let's talk briefly about the next stage of the task launch process. And this is the stage where ECS collects your running container to a load balancer. Obviously, this isn't relevant to queue processor, but it is relevant to all APIs and web workloads. As Robert walked us through, before ECS starts sending traffic before load balancer starts sending traffic to a container, the container needs to pass health checks. Now, in order to, and there's two key configurations that basically determine how quickly and how frequently the ELB health checks are performed from the load balancer. One is the health check interval period, and the second is the count. When you multiply these two values together, the default comes out to be about 2.5 minutes, which can be pretty significant. Now, if you've done a good job architecting your application well, you should likely not need, your application should not need this amount of time. You can reduce this time significantly and speed up your task launches by a lot. However, I want to urge a little bit of caution. While you obviously want to make sure your tasks launch fast, you don't want to skimp on the health check either. As Robert alluded to earlier, you make use of the lazy loading, the just-in-time concepts in Java well. Make sure that like the right set of application dependencies are included in your, or for the application itself are included in the health check, so that your application, once it's deemed healthy, it can actually serve end user requests. It's not just advertising itself because it is running. Now let's quickly move forward to the next step of or the other set of levers that you have to accelerate your deployment, and that's accelerating task shutdown. Again, I want to urge caution here. It's super important to make sure that you're not sacrificing availability when you're speeding up some of these things. So keeping in mind things like graceful shutdown. So implementing SIG term handling inside of your containers is super important. Even though you want to minimize the amount of time your application takes shut down. So strike that delicate balance. One configuration that I do want to poke at is related to load balancers again and relevant to your load balance applications. So in the deactivating state, ECS basically ECS tells load balancers, hey ELB, this task is going to shut down, stop sending new traffic to it. Now when ECS does that, ELB stops sending new traffic, but there's still previous requests that need to be that might need to be honored before and processed before the task can shut down. And in order to do this, the load balancer gives up to a period, or by default a period of 300 seconds for any outstanding request to be processed. In most cases, for most well-architected container apps, you don't want this number to be this high. You want this number to be much lower, 30 seconds, or could go even lower depending on what the nature of your application is. However, if you're using, say, a long-running application, your application uses long-running connections like, say, WebSockets, then in that case, you might still want to have a relatively longer timeout. But that depends on. But for most other applications, processing any pending request should not take that long. So this is a relatively easy, simple, straightforward optimization that you can use to quicken up your task shutdown in ECS. Now we've spoken a lot about deploying quickly and safely. But as important as it is to deploy quickly and safely, it is also super important to make sure that you have the right observability in place to monitor your deployments and detect failures. First up, visibility into your deployments themselves. And again, this is the new concept I talked about earlier. ECS now by default gives you visibility into your deployment. So we have introduced a new set of APIs as well as a console experience which allows you to see your history of deployments. You can see the past 90 days of deployments for your ECS service. You can see whether a deployment succeeded, when the deployment started, when the deployment finished. You can also see things like what was the service version before the deployment started, what was the service version after the deployment ended. All of that is available by default out of the box for your ECS services now when you use rolling deployments. And this is a super useful construct, especially when, as I said earlier, when you're troubleshooting deployment failures after the fact. The other thing that related to deployment monitoring I want to talk about is, as I said at the beginning of the presentation, inevitably there will be times when deployments fail. And when deployments fail, you want to make sure you have the right monitoring and safeguards in place to protect your deployments from impacting your end users. There are two key safeguards that ECS provides in this regard. First, ECS circuit breaker, and second, CloudWatch alarms. Let's talk about circuit breaker first. It's probably my favorite topic to evangelize whenever I speak to customers. Just turn on circuit breaker. It's as simple as setting a single flag in your service, in your deployment configuration for your service. All you need to do is turn it on, and ECS will automatically monitor for task launch failures as well as tasks that fail to get to a healthy state. And in case that that exceeds a threshold, ECS will automatically deem the deployment as failed. Optionally, you can also tell ECS that, hey, ECS, I want this application to be rolled back when the deployment fails, and ECS will do that automatically for you. One thing I want to call out that we also did earlier this year is we made circuit breaker much faster and more responsive, especially for your services that have less than 10 tasks. So in case you tried out circuit breaker previously and found it to be slow to respond, I'd say try it out again. It now functions much more effectively for services which have fewer than 10 tasks. The other and slightly more nuanced safeguard that you have for your deployments is CloudWatch alarms. So while circuit breaker monitors tasks that simply fail to start, You can use a CloudWatch alarm to monitor your deployment to detect any regressions in your application. So think like you've rolled out a new application version. Now there's a memory leak causing memory utilization to spike, or there's something causing CPU utilization to spike, or you're seeing an increase in the number of 500s, or you're seeing an increase in the API latency. All of those things can signal that the deployment is bad and intervention needs to happen. So in order to automate such actions, you can tell ECS that, hey ECS, this is an alarm that I've configured which monitors the metric that I care for my application, and ECS will automatically monitor that alarm, and in case that alarm goes into the alarm state, ECS will fail the deployment and optionally roll back the deployment if you configure a rollback. One important concept I want to talk about here is that when you configure a CloudWatch alarm for your deployment, there's a little bit of a challenge here that because there's a latency associated with metrics being propagated, whether that be CPU metrics or ALB metrics or any other metric that you're using, it can mean that by the time your deployment would normally end, the alarm may not have gotten the opportunity to go into the alarm state. In order to prevent that from happening, what we do as part of when you configure an alarm or set of alarms to monitor your ECS deployment, ECS doesn't deem your deployment to have ended just when new tasks are running and old tasks have been shut down. ECS waits for a period of time after this has happened to basically make sure that the alarm doesn't go into an alarm state. This bake time is automatically computed by ECS based on the configuration for your alarm. You don't need to do anything about it, but it's something that we did to make sure that the feature stays responsive and you can does the right thing, even in case there's a delay in the regression showing up in your metrics. Obviously, it's super important to choose the right metric for when configuring the CloudWatch alarm for your deployment. So in Nikki's scenario for her API and web applications, my recommendation would generally be to use something like the HTTP 500s count on the load balancer, or to use the latency measured in the ALB target group as good indicators that the deployment is not in a healthy state and needs to be rolled back. Also, obviously, infrastructure utilization metrics like CPU and memory. On the other hand, for her queue processing service, my recommendation would be to use SQS metrics. So things like the depth of the DL queue, or rather the dead letter queue. So in case there's a spike of a lot of messages in the queue that are failing to process successfully, that's probably a good indicator. Obviously, utilization metrics can still be used. In general, almost always a good idea to use both CloudWatch alarms and circuit breaker for your deployments. Even if you don't configure CloudWatch alarms for your deployment, please do configure circuit breaker. It's a very simple safeguard, saves a ton of hassle for a lot of customers. So that's always one of the things I harp on a lot. One other thing that I want to call out from the observability standpoint is, again, going back to the beginning of the presentation, deployment velocity and frequency. So if you use Container Insights, ECS emits, you can see a metric that tracks the number of deployments in ECS. And you can see that at a cluster level as well as a service level. So in order to measure and track the velocity of your teams or a particular team, you can use that metric to see how quickly you're shipping new deployments and compare that over time to see whether you're seeing the right level of gains in your deployment velocity. Now, I will hand it back to Robert, who will walk us through key takeaways for today.
Cool. Thank you, Vibhav. That's awesome. So there's quite a lot of things to digest from a safety, velocity, and speed. But I'm going to summarize kind of the key takeaways and actions that you could take today. So there's a range of Amazon ECS features that you can utilize. And I think something that you can do today is review your role and deployment configuration for balance and speed. Maybe for non-production, you want to set a lower minimum percent. And maybe for production, you want to up it to the defaults 100% and 200%. So review your rolling deployment configuration. Review your health check configuration to prevent bad changes reaching production. Are they the right settings? Is your application actually healthy when those health checks pass? Is it ready to start receiving traffic? Validate your applications can gracefully shut down. So during that voluntary disruption, when a SIG term is sent, can my application actually gracefully shut down, or is it forcefully terminated after that expiry? And explore circuit breakers. If you don't have automated deployment rollbacks with wrong deployments, explore the use of circuit breakers and see how they could help you build more resilient deployments. And this is mine and Vibhav's photo opportunity, but really an opportunity for you to continue learning about Amazon ECS. So today on the left-hand side, you can find the assets from this session and all the links. So this links to things like the workshops, the presentation that we shared today, and also some of the blogs and the what's news that we referenced. We've got the Amazon ECS best practice guide built from working with a lot of our customers over time, and then the Amazon ECS workshop to get hands-on. So I do highly recommend to continue your learning journey today is to check out some of the assets from this session. And thank you very much. We hope you enjoyed the session, and it's going to help you have more resilient deployments going forward. So thank you for your time.
Thank you so much.